So today we're going to be solving quadratic equations by using the quadratic formula. Now, if you recall, a quadratic equation is an equation that's in the form ax squared plus bx plus c is equal to 0. We have solved quadratic equations. The first method that we used was factoring. So you can solve a quadratic equation by factoring, if it factors. But not all quadratic equations will factor. So factoring doesn't always work. The second method that we used was the square root method. And this method doesn't always work either. You can only use the square root method when you have a quadratic equation in this form, when it only has a quadratic term, when it doesn't have a linear term, when it doesn't have the bx term. So that doesn't always work. And then the third method that we used was using Desmos by graphing it and finding the x-intercepts. But you might not always have Desmos available to you. So there's a fourth way. In the fourth way, this method always works. The quadratic formula will always work. So let me show you the quadratic formula. So to solve for x, it says x is equal to negative b plus or minus the square root of b squared minus 4ac. All of this is over 2a. Okay? So there's two formulas up here that's very important to know. The standard form, this is how you get your values of a, b, and c, to plug into this form, into this equation, which is called the quadratic equation. This is read negative b, but it would probably be helpful if you think of it as the opposite of b. Instead of reading it as negative b, read it as the opposite of b. So it's the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So let's solve some quadratic equations using the quadratic formula. And again, this method here, the quadratic formula, will always work no matter what type of quadratic equation you have. So here's my first quadratic equation. 2x squared plus 3x minus 7 is equal to 0. Remember, this is the standard form. ax squared plus bx plus c is equal to 0. So your first step is to identify your values of a, b, c. So in this equation, a is 2, b is 3, c is negative 7. Then what we're going to do is we're going to take these values and plug them into the quadratic formula that I have up here on the board. So this first one, we have negative b. Again, remember that's the opposite of b. So b is 3. So the opposite of 3 would be negative 3. So I'm going to put negative 3 here in place of that. And then I got plus or minus b squared. Well, take 3 and square it. 3 squared is 9. Minus 4 times a, and a is 2 times c, and c is negative 7. And this is all over 2 times a, so 2 times 2. So your first step is to just plug in all your values into the quadratic formula. I like to see this step. So when I ask you to show your work, show this step. Now, let's reduce this, okay? Let's simplify this. So the negative 3 out front, we can't do anything with it. 2 times 2 on the bottom is 4. So what we got to do is we got to figure out what's under this square root. Well, we're going to have to do order operations. So the first thing we're going to have to do is our multiplication. So we can't do anything with this 9. So I'm going to multiply these last 3 numbers together. So I got negative 4 times 2 is negative 8. Negative 8 times negative 7 is going to be positive 56. So I'm going to put plus 56 here. So I got 9 plus 56. 9 plus 56 is 65. Okay? So now what we want to do is we want to see if my square root can be reduced. If it can't be reduced, that's my answer. If it can be reduced, we got to reduce it. So 65, is that a perfect square? It's not. Is there a perfect square that goes into 65? What are the factors of 65? 1 is 65. What else goes into 65? 5 does, right? 5 and 13. Are there any other factors of 65? No. Are any of these factors of 65 perfect squares besides 1? Because 1 doesn't really count. It goes in everything. Nope, nope, nope. So this is reduced. This is your answer. You still have 2 roots here. There are actually 2 roots. But you can just write it like that as 1. This looks like 1 root, but it's actually 2 roots. The 2 roots are negative 3 plus the square root of 65 over 4 and negative 3 minus the square root of 65 over 4. These are my roots. These are my solutions. All right, let's try another one. So again, we've got our standard form. Ax squared plus bx plus c is equal to 0. Let's identify our values of a, b, c. So a in this particular problem is 4. B is negative 1. And then C is 4. Let's plug our values in. So we got the opposite of B. Well, B is negative 1. The opposite of negative 1 is positive 1. So put 1 there. B squared. So take negative 1 and square it. So negative 1 times negative 1 is going to be positive 1. Minus 4 times A, and A is 4, right? Times C. C is also 4. And this is over 2 times A, and A again was 4. So what do we got here? Let's work this out. We got 1 plus or minus, I got my square root. 2 times 4 is 8. So up here, I'll do my square root. I got 1, and then let's multiply these together. 4 times 4 times 4 is 64. Is this 64 positive or negative? Well, how many negative sides do I got? 1. So I got an odd amount of negative signs, so it's going to be negative 64. So 1 minus 64 is negative 63. Now, if you remember when we were doing this by graphing, this is going to be one of those graphs that doesn't intersect the x-axis. So when I graph it, I might get a parabola that looks something like this. It won't cross the x-axis. So what does that mean? It has no real solution. So the solution to this is no real solution. How did I know that? I knew that because I had a negative under my square root. You can't take a square root of a negative number. If you think about it, the square root of 4 is 2. Why is it 2? Because 2 times 2 is 4, right? So if you try to take the square root of -4, what number can you take times itself twice to get -4? There isn't. There's not a number. If you try -2, that's not going to work. -2 times -2 is +4, not -4. There is no real number that you can take and times it by itself to get -4. So when you get a negative under your square root, all you gotta do is write no real solution. Eventually, we will learn how you find the solution. The solution is actually imaginary. We're gonna learn about this number called the imaginary number. But for now, I just want you to write no real root or no real solution. All right, let's try one more example here. Let's look at this example. 6x squared plus x minus 1 is equal to 0. So again, let's identify our values of a, b, and c. So a is 6, b is 1, c is -1. Then the quadratic formula is -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So the opposite of b, so the opposite of 1 would be -1. b squared, so 1 squared is 1. And then a is 6, so plug 6 here. And then c is -1, so plug -1 here. And then a, again, is 6. So again, this is the first step that I always want to see. I want to see you actually plugging your values in for a, b, and c. So show that step when I ask you to show your work. All right, so now let's simplify this. So we're going to have -1 plus or minus the square root of something over 2 times 6, which is 12. Let's figure out what's under the square root, okay? This is actually has a name. This is called your discriminant, okay? The thing under your square root in the quadratic formula is called the discriminant. So let's calculate the discriminant. So we got 1, and then I got -4 times 6 is -24. Times -1 is +24. So under my square root, I got 1 plus 24. 1 plus 24 is 25. What's the square root of 25? 5. So we can reduce this. So this will be -1 plus or minus the square root of 5 over 12. Now, if you think back to a lesson that we had a couple of days ago, you got to reduce this. When the square root is a perfect square and you got this plus and minus in between, you actually got to find the two roots. So what we're going to have to do is we're going to have to take the 2 halves. We're going to do -1 plus 5 over 12, which will give me 4 over 12, which is 1/3. So one of the roots is 1/3. Now, let's do the bottom half. Let's use the minus half. So let's do -1 minus 5 over 12, which gives you -6 over 12, which is -1/2. So the solutions to this quadratic equation are 1/3 and -1/2. Those are the roots. Those are the zeros. If you are graphing these, this is where they would intersect the x-axis.